So I'm very happy to introduce Trisha G. Trisha G is a developer advocate at JetBrains, and she's going to talk about the importance of readable code.
Thank you. I just realized I didn't turn my mic on, which wasn't very helpful. Right, hi, yes, I'm Trisha. I work for JetBrains. Apparently we invented Kotlin. I'm not here to talk to you about Kotlin because actually I don't use it and I don't know very much about it. So instead, I'm going to talk to you about readable code and about the balance we have between reading code and writing code in our day jobs. One thing that struck me and my colleagues recently, we were talking about code reviews actually, was that a computer language is the only language where you learn to write it before you learn to really read anything. Oh, this isn't working. Typical. Never mind, I will just press the button. There we go. This is my youngest daughter's favorite book. She is 1, nearly 2. Clearly, she can't read it, and she certainly can't write. My eldest daughter is nearly 4, and she is kind of vaguely starting to read stuff, but she is also not able to write, because the way that we teach normal languages is we teach people how to read stuff before we start teaching people how to type things into anything. I live in Spain at the moment. I've lived there for 6 years, which means that I'm learning Spanish. I've been learning Spanish for 6, 7, 8 years, and I still don't really speak it, but I certainly don't write it. When you're learning a foreign language, you learn it. So this is Duolingo, which is amazing, by the way. I've tried every platform because I'm desperate to fast track my way to learning a new language, which is impossible. You just have to put in the time. Okay. So when you're using something like Duolingo, you get multiple choice. You don't have to type the answer. You also have the way of it just kind of gives you some vague words that you might want to structure into a sentence. Only when you get to level 5 does it say, you should actually start typing the stuff in letter by letter, because you should be learning how to read, how to listen, and how to speak before you start learning how to type anything into the computer. But when we talk about computer stuff, we're always talking about writing code. We are never talking about the skill of reading code. We accidentally talk about, oh yes, I had to read this code in order to write it. But we don't have any conference sessions on this is how you read code. Okay? So yes, we're always talking about writing code. We are never talking about, we don't value the skill of reading code. There is no way of evaluating your ability to read and understand code. And I think this is a little bit unbalanced. Because in the real world, obviously, we have a programmer, we have some code, and we have the computer. And we talk about how to write working code. That's kind of probably the most important thing. The computer sort of vaguely needs to understand it and do what it's supposed to do. In more recent years, we've talked about readable code. We've talked about writing readable code, the ability to write something so that the other consumer, a programmer, can understand what you've written. We don't talk about how we read that code. We just, once again, focus on the writing aspect, not the reading aspect. So fine, so maybe that's because reading code is really not that big a deal. Maybe we just don't really need to do this. So why would we want to read code? We're going to read code for fun. Good, that's the right laugh. So this is from a blog post called Programming Sucks, which is very funny. Every programmer occasionally, when nobody's home, turns off the lights, pours a glass of scotch, puts on some light German electronica, opens up a file on their computer. They read over the lines and weep at their beauty. I don't know about you, but I've never done this. We don't do this. You don't sit down at home and go, oh, I could read a book, or I could watch Netflix, or I could open a file on my computer and read it. Shits and giggles. No, we read code often to review it. I know that you have a code review culture here. I don't know how much you like code reviews. Most people hate it from both sides of the reviewing and the authoring. When we read code to review it, we're usually looking to critique it, or more often than not, criticize it. We're reviewing code to find problems. I mean, that's kind of normal because the point is for a lot of code reviews, especially these gateway type code reviews, the idea is to find problems so that the problems don't go into production. So we are taught how to read code in a critical manner. Oh, this is not the way it should be. This doesn't work. This is not awesome. I don't understand it. So that's kind of how we are taught more often than not to read code. Another reason we want to read code is we want to find out what it does so I can use it. Or more often than not, I want to find out what it does so I can change it. Because we are developers. Our job is to write code. So we only ever read code when we're thinking about changing it, writing more code, or editing the existing code. We really should be reading code to understand it. Because once again, back down to the analogy of like reading language stuff versus writing language stuff. You can't sort of sit down and make changes to something until you understand it. But that's kind of what we do. We like read code to kind of get a vague idea of vaguely what it does, and then hack away at it to change it to see what breaks. I mean, to fix it, obviously. So we don't really, again, we don't read code to get a feeling for what does the code do. Whether it's a new code base that we're unfamiliar with, an open source code base that we're kind of trying to get to grips with, or whether it's literally just the bit of code that's in the bug we're trying to fix or the area of the feature we're trying to implement, we don't take that time to just read it and understand it. Okay, so what are the problems that face us when we are reading code? Because after all code that we write is self-documenting. So all we have to do is RTFM, right? I'm going to read the code and it documents itself to me and I fully understand everything that is in the code. This is also from the same blog post. This file is good code. It has sensible and consistent names for functions and variables. It's concise. It doesn't do anything obviously stupid. It reads like poetry written by someone over 30. But in the real world, we don't have good code, do we? We have bad code. That's the problem with reading code. When we read code, there's just lots of bad code out there. Obviously not at Google. Obviously, you've got great code. I don't mean you. I mean generally, in the places I've worked. No, none of them either. No. Bad code. There's a lot of bad code out there. And there's bad code out there because I didn't write it. I didn't write it, so I hate it. I didn't write it, so I hate it. I hate it mostly because I don't understand it, because I didn't write it. Or, as is often the case with me, I did write it, but I don't remember. I don't know what I was doing. I don't know where I was at the time. And this is obviously yesterday, not like 5 years ago. So I wrote it, but I don't remember. And I wouldn't do it that way now because I read something yesterday that means we don't do it that way anymore. And of course, on top of that, technologies change. Java has moved to a 6-monthly release cadence, which is like mind-blowingly fast to the Java community. Because we had a nice steady state for like 6 years when nothing changed, and we kind of got used to that. Now we're getting it every 6 months. We're like, oh my God, another version of Java. Java 14 is out. 13. I don't even know where we are now. Java 13 is out now this month. So technologies change, particularly Java is moving much more rapidly, and fashions change. Even if we were using Java 1.1, which is what I learned at university because I'm old, if I was writing Java 1.1 now, I wouldn't write it the same way I wrote it 20 years ago because fashions in the way we write stuff has changed over that time. We've moved more towards sort of immutable and a more functional style, even if we're not using functional languages. So the fashions in how we write our languages and how we write our code change over time as well. Assumptions are hidden. This is particularly true if you've got experienced people working on the code base, or if you've got experienced people working on the code base and less experienced people coming to the code base. They don't necessarily know, we do it this way because of these technical reasons, or we do it this way because that's the architecture, or we do it this way because that's what the business needs. We just see the code. So when you're writing stuff, you write it with all of your internal assumptions, and you don't always get to codify those. So someone coming along and reading it is just like, well, this is bad code, because they don't really understand what was going on when you were writing it. One of the main reasons why reading code is difficult, oh, by the way, I'm speaking really fast because I had so much coffee this morning. I'm not at all jet lagged from landing at 10 o'clock last night. One of the main reasons why it's difficult to read code is because people don't read. If you do things like organize events, like user group events or anything like this, you will know this because you write an event and right at the top you say, this event will not be recorded or streamed. And the first comment will be, is this event going to be recorded? Like, what did I just say? Why did I bother even writing this stuff down if you're not going to read it? And obviously, I read stuff properly all the time. This doesn't apply to me, it's other people. But in fact, we don't really read stuff properly because we're overwhelmed. We're thinking about this thing over here. We were looking at this code. We're looking at this code now, but we're not really paying attention to it. Or we haven't got the context loaded, or we skipped over it, or we're reading it on non-native language, whatever. Reading is quite a difficult thing to do. So when we're reading code, we quite often come to the conclusion of, I don't understand. And this will lead us in often 2 directions, sometimes both at the same time. The code is bad. I don't understand it, the code is bad. It's not readable, it's not clean, it's not whatever. Or I am bad. I don't understand it, so I must be terrible. Your reaction possibly depends upon where you are on this learning curve. If you Google it, which obviously you Google, so you probably would, this is at the top peak there. Sometimes it's called like Mount Stupid, which is a bit unkind, or the Dunning-Kruger effect. So right at the beginning, you're like, oh, I learned something, and so I know everything about everything. And then you descend into what's called the Valley of Despair, which is where most of us as programmers spend our lives. Oh my God, like, what is this? What am I doing? So if you kind of live on Mount Stupid or in like super experienced, you might conclude this is bad code. And if you live where most of the rest of us live, you're going to think, oh my God, I'm just really not very good at this. And the funny thing about this learning curve is that you don't know which of these two pools you're in. Okay. I don't know if I'm at the top of Mount Stupid or if I really do know what I'm talking about. So yes, that's quite challenging. So, okay, that's enough of my ranting for the moment. Why don't we go ahead to some actual tips to help us when we're reading code specifically? The first tip is not very popular. You will get better with practice. But this is fine because this is what we do in our day job anyway. We read code. But it's not just about putting in the time. It's about something called deliberate practice, which Kathy Sierra talks about in her book, Badass Making Users Awesome. Has anyone read this book? Right, well, you should all read it. I thought one of you would have done. If you write software for users, if you write documentation, if you do developer advocacy type stuff, if you do anything which talks to other human beings, so I'm hoping that's the majority of you, you should read this book. So anyway, she's talking about something called perceptual learning here. After enough exposure with feedback, your brain begins detecting patterns and underlying structures without your conscious awareness. With more exposure, your brain fine-tuned its perception and eventually figured out what really mattered. Your brain was making finer distinctions and sorting signal from noise, even if you couldn't explain how. So with continued exposure to the same types of things and a feedback loop to tell you whether you're doing any good or not, your brain will just get better. You will learn. So the way we get better at something is just to practice, practice, practice with what Kathy Sierra calls deliberate practice. Now, obviously, there are different places to practice. So I'm assuming you're going to be reading code in your own code base, in the code that you're working on. That might seem like a stupid thing to suggest because, of course, you're going to be reading code in your code base when you're writing code. I'm suggesting that we make some time to actually start reading for the sake of reading and understanding and learning without having in the back of our heads, how do I change this? What am I going to fix? How am I going to write something? Let's read it so that we can actually start to comprehend it, to get a feel for it. When you're reading your code base, it's not like, and obviously you live in this code base and you've worked with it for, I don't know, anywhere from like, 1 day to, I don't know, 10 years, I don't know. But a code base is continually evolving. So it's not like you can learn it once and then you never need to read it again. It's totally worth like dipping in and out and reading and understanding different areas as new features are added, as new architectures are adopted, as new trends come into play. So your code base is a good place to practice reading. Obviously, you can read open source code. That's kind of interesting because it's usually code that you didn't write and don't have any background on. Is often poorly documented. So it's a good place to figure out how to learn stuff without any pressure for you to improve or change it or write anything to it. I also mentioned libraries you're using because it doesn't have to be open source libraries. I assume you're using each other's code and other code internally that you're not writing. Things like coding katas and practice, and a lot of coding katas and learning sites are obviously once again focused on learning to write code, but you can still use some of these small examples to get a feel for particular patterns and how to spot them when you see them. So those are some places to practice. So that's the first tip. The first tip is practice. There is no quick fix to this. This is just something that will come with time the more we do it, and the more we do it deliberately on purpose, trying to improve our reading skills. The next tip is reading is not the same as reviewing. Now, imagine you're reading Jane Austen and you're like, well, I don't really like the way she wrote that sentence, and I really would have put chapter 2 before chapter 1, and actually I just can't get any further reading this book until she makes these changes to it. I mean, that's kind of how we read code, right? That's what we do during code reviews. And maybe there is a place for that in code review, depending on the purpose of your review. But I'm talking about reading for the sake of learning. So we have to learn to accept what is there. It is, for example, like a book or a blog post. I'm reading this to get something out of it. I'm reading this to learn. I'm not reading this to suggest changes. I'm not reading this to make changes. I'm reading to learn. So I have to learn to accept that it is the way it is. It just is what it is. Time to move on. And it's just a lot better than getting caught up on, oh my goodness, they use tabs, not spaces. So when we're reading code, we should not be judging. We are exploring. We're navigating through the code base. We should be making notes. When I'm making notes, when I'm reading code, I'm quite often, I sort of have notations for my different notes. So I mark my questions with a big question mark, so I can tell the difference between the questions I have, the things I've discovered, and maybe things for further investigation, that kind of thing. So I'm going to make a whole set of notes. And draw diagrams. I mean, not everyone sort of thinks visually, but it does make sense to sort of draw some boxes or circles with arrows to kind of capture what you think are the dependencies or what you think are the flows of data. And I'm not talking about doing like formal UML diagrams or anything like that. One of the things that I think trips up a lot of programmers is that we worry about, like, are we doing the right sort of diagram? Are we capturing stuff at the right level? When I worked at a financial exchange, we just drew like boxes and lines just to kind of vaguely talk about, make shapes around what we were talking about and to help you visualize stuff. And that's kind of what I'm talking about, really informal scribbly diagrams that you can show to each other if you want to. But most importantly, don't change the code. We're reading the code. We're not judging the code. We're just trying to learn the code. Okay, next tip. Code bases have a shape. We should know this already. Code bases have a shape. I studied Shakespeare at school. You're not supposed to be able to read this. I don't know if you study Shakespeare in the States, but I remember thinking, like, what a massive waste of time. I'm never going to use this. Now, here it is in my presentation. One of the things I remember from studying Shakespeare at school is that Shakespeare has two different distinct styles when he's writing. The first one in the top half here is prose. He uses prose for lower class characters or comedic characters. And the second style is verse, which is the second half here. He uses it for the nobles, for the main characters, and for when someone's making a specific point. So you can see from the shape of what he wrote that it has that there's different purposes, and they're visualized even without you having to read it. So the actors, the audience, they kind of get a feel for like where they are in the play according to the shape of the text. I mean, they're not reading the text, but it flows in a different way when you're saying it. So code bases are not dissimilar. They have a shape, they have a structure. Obviously, we have things like services, modules, packages, layers, patterns, all the stuff that's up here. So it depends a bit on your code base. It depends a bit on how things are structured. But these are the sorts of things I'm talking about when I talk about the shape of your code. So let me open up IntelliJ. Look, 20 minutes into the talk, and now I'm opening up IntelliJ. I think I did well not to go straight into the tool. So I'm talking about, obviously, individual files. This is a real code base. This is an open source library called Morphia. It's for talking to MongoDB. I use this because I used to work for MongoDB, and it's a nice way of just demonstrating real code that is lived in, that's a fairly, it's a code base that's been around for a while, so it has some interesting patterns in it sometimes. So this class has obviously like fields at the top. It has like, that's a constructor. Let's skip over that briefly. Business logic in the middle, and then getters, setters, and toString and stuff. So the file itself has a structure. It's fairly well organized. The project itself also has a structure. It has modules. It has a package structure, obviously, and these packages are, in this case, are split by kind of business domain, if you like, because obviously different projects do things different ways. Some like to split things by layers. Some like to encapsulate things by the business domain. And the goal is not to get into a religious war about whether we're going to split by layer or split by domain. The goal is to look at what's there and try and stick with the same consistency and same structure that we have here. And so, yeah, so we can see inside our IDE vaguely what the shape of the system is, including things like all these deprecated classes that we're not supposed to be using. So code has a structure, and we can get a feel for that structure by kind of loosely navigating around the project that we're looking at. Code bases have a dialect. this is something I think that I've only just really started to realize, like after about 20 years of coding. I'm like, there is no one right way to do stuff. Obviously, there's an idea of clean code, and like I said, fashions and what seems to be best practice at the moment. But ultimately, when you get to a code base, it is an existing code base with its own dialect, its own way of working, which I'll go into in a minute. Let's go back to Shakespeare. So, if music be the food of love, play on, give me excess of it, that surfeiting the appetite may sicken and so die. Like, I don't think anyone in the 17th century even spoke like this. But, this is not how real people speak, but this is Shakespeare. And you can't really appreciate Shakespeare unless you look at the verse and the language from 400 years ago and the words that he uses. So when you're studying Shakespeare, you're like, okay, I don't really understand it. Well, this is actually fairly easy to understand. But quite often you're like, I don't really get it because he uses words I don't really understand. But you just kind of have to get into it because that's sort of the point of Shakespeare, if you like. Let's go one step further. Let's look at Chaucer. So this is written in, says the Canterbury Tales, 1387 to 1400. So we're talking about the 14th century here, way before spelling standardization, as you can tell. And I'm not going to read it out because English was actually pronounced in a different way then as well, because it's like so long ago. So you read this and you're just like, okay, it's English, right? Probably. And my first instinct is to go, right, that's not right. Don't understand any of that. I'm going to translate it into modern English so that I can actually understand it. But that's completely the wrong way around. How can I translate it into modern English in order to understand it, right? Aren't I supposed to understand it first and then perhaps do something with it? So if you're studying Chaucer, you do find a lot of like modern translations of it to sort of help you with this. But again, part of the point is to kind of study Chaucer for being Chaucer. I mean, again, I don't think you're going to get it out and read it with some like German electronica in the background to just really enjoy it. But this is if you're reading Chaucer, you kind of have to take it with all its old English and everything. That's kind of the point. And I think we need to be the same with our code bases. We need to understand that it has a dialect. It was written at the time when it was written. Everything was done for a reason at the time. Like, let's not be taking the red pen out and crossing it out and go, oh, I don't like this and I don't like that. Let's get to know what the dialect is. Let's kind of learn to live with that particular dialect so that we can have a bit of standards and consistency with when we're starting to eventually write code in there. The dialect is going to be dependent on, obviously, things like the language you're using and the libraries that you're using, because the libraries dictate the shape and the way that you work. Obviously, there's going to be a function of the age of the code as well. And pattern standards, the code shape that we've already looked at also has an impact on how we're going to be writing our code. I wanted to mention a little bit, though, this idea of false friends. If you've studied a foreign language, there is this idea of words which sound similar but are not the same. So, for example, in Spanish, embarazada is not the same as embarrassed. For those who don't know, embarazada means pregnant, which is not the same as embarrassed. I mean, it can be quite embarrassing being pregnant, but it's really, really not the same thing. So there are plenty of these examples of words in foreign languages, especially sort of related languages like, the Latin influences of English and French and Spanish, where words sort of sound the same, but they don't mean the same thing, and it can trip us up. It can lead us into making mistakes. I think this idea applies just as well to things like design patterns and coding styles. So, for example, MVC, right? I say MVC, you think model view controller, and you think of your mental model of MVC, and you know perfectly well that you've worked on like 3 different systems with 4 different types of MVC in them, okay? Because if you're working, for example, in like a Spring Web MVC world, the model is very lightweight. I don't know if it's true now. The model was very lightweight. It's just a hash map with a bunch of values in. And I worked somewhere else where the model is like fully fledged domain objects with their own like business logic inside them as well. So MVC, I'm going to come to a project that's got MVC in it with my mental model of what MVC means. And I'm constantly going to be tripping against the difference between my mental model and the actual implementation in that code base. So we need to be aware that sometimes familiarity might actually cause us more problems than being unfamiliar with something. We need to understand what's really there in the code base rather than sort of implant our own expectations onto it. I've got like loads of other examples, but things like, you probably don't use Jenkins as a build server, but like Jenkins If you put on your CV, oh, I've got experience with Jenkins, it means nothing because every place that you work uses it completely differently. It might as well be a completely different tool. Okay, so we need to understand that our expectations, we can't be implanting them on the code base. We need to be reading what's really there instead of making assumptions about how we think things work. Code is not linear, of course. We know this. Code is not linear. Code is not a book. You don't read it from end to end. I actually did go into an interview once where they printed out like sheafs of code and said like, analyze this. You're like, what am I supposed to read it from beginning to end? Like, that's not how code works. Code is much more like hypertext. Do we call it hypertext anymore? It's just how the world works. So, you know, you're reading something. I really was reading about the Peninsular War. Don't even ask me why. So of course I'm on Wikipedia going, oh, I'm going to click on here and follow this link. It's really interesting until I end up with like a backlog of all these, like, how did I get to Silesia? What was I even trying to find out? I don't really know. And I have to have this mental stack, or, you know, the browser does that for me. And of course in recent years, because I'm old, like a long time ago, Chrome came along and fixed this and said, here, have tabs. That makes life a lot easier. Like, oh, thank God, tooling. Tooling can fix a lot of our problems. And it's not just things like the browser, things like Wikipedia also gives you pop-ups so you can decide whether or not you want to click on that link or whether that's just sufficient for you to get a feel for it. So when we're talking about non-linear paths, non-linear stories, then really we should be looking at our tools to help us with that. Fortunately, I work for a company that makes an IDE, and IDEs do this for us. So I'm going to give you a really quick overview of some of the navigation tools inside IntelliJ IDEA, which I'm assuming you all know, so you can doze if you want to. But if you don't know, then you can pretend you knew it all along. Right, so navigation. The first thing I'm going to say is that when I'm using IntelliJ IDEA, I try to just have the code on there. I don't have any toolbar buttons. I don't have a navigation bar at the top. I just close everything down because really what matters to us is the code. We should not be using the mouse to navigate through the code, and we should not be using other buttons and things. We can use the code to navigate through the code. So let me give you an example. Let's see, what are we looking for? We are looking for, so I'm going to navigate directly to the class I want, which is default query factory. I can use in IntelliJ IDEA, oh good, it's really tiny, you can't see anything. You can use camel case to navigate directly to the class that you want, or you can even, if I can't remember, I just want some sort of default factory, it'll give me a list of everything which matches that sort of pattern for the class. Like I say, you probably all know this, it's fine. Then I'm inside a class, and I'm looking at something like, I see that I have a query here. So if I want to find out what that is, I can use quick documentation, which is the thing I always forget. And no, there we go. So my excuse is I switch between the Mac and the Windows machine, and so that's why I don't remember all the shortcuts. The shortcuts are, go away. The shortcuts should be popping up on the top so you can see what's there. How did I get it to do that? Why is it open in there? Anyway, so you can see that this is an interface called query. And if I want to find out more, so that's kind of the equivalent of the pop-up on Wikipedia. If I want to find out more, I can navigate directly to the interface by doing Control B, which is go to. Or that's probably not super useful because I'm less bothered about the interface because I can code against the interface. I'm more interested in navigating to the implementation. So Control Alt B goes to the implementation. In this case, I only have one implementation, so it takes me directly to that implementation, and then I can take a look at what's going on there. Or if I've got something with more than one implementation, when I do Control Alt B, it gives me a list of which implementations I want to go to. Okay, so I can very easily go to that, like that. Control Alt arrow will take me back to where I was before. One of the other things which is super useful is Alt F7, which is the ability to find the usages of this query so I can navigate directly to any of those. Okay, what else can I do on the navigation? So let's go into query. Tests are a good thing. We should all be writing tests, right? That's an easy thing to do. We were just moaning back there about how difficult it is to write good tests. So if I do Control-Shift-T, it takes me to if there is a test, it will take me to the test. Query surprisingly, is like a fundamental part of the talking to MongoDB bit. So there's like loads of tests on queries. So it says, which one of these do you want? So we'll go to like test query. So I can navigate directly between the test and the test subject. So I can, if I'm doing something like TDD in particular, it's a really easy way to just flip between the two things. What else do I want to show you? Oh, recent locations. Control, Shift, and E gives me the recent locations I went to, like literally the snippets of files that I've been looking at. So not just going like backwards and forwards between the whole files, but just to the specific part of a file that I was looking at, which is really helpful. Because obviously when you're writing something, obviously we're not talking about writing here, it's supposed to be talking about reading. But if you've been like making your way through the code base, you kind of might want to backtrack to where you were when you saw this thing. So recent locations is useful for that. Another quick tip, Control E, which is recent files, also gives you all of the tool windows. So you can use Control E to just quickly navigate to something like, I was going to say the Gradle tool window, but you probably don't use Gradle. But, you know, so I can say, oh, I don't have Gradle in here. So I can go to Maven, and I can open up the tool window from inside there. Okay, so there's like, oh, yeah, and worst case, if you don't really know what it is you're looking for, I don't know, firstly, Control-Shift-F is find in path, so I can look for anything. I just basically do a file search, which is kind of like a brute force way, because really you should be looking for things like specific implementations, or you should be using the strength of Java to be able to navigate through the code. But sometimes you do just want to do like a textual search. And something which is super useful, very powerful, is structural search. Let's see. So I'm going to use find action to do that. Structural search. And then I can use things like, I use this to do things like find me all log methods which have like at least two parameters where one of them is not a lambda, because like you can have log methods which take a lambda expression, so they're lazily evaluated, so it's much better performance. So I can use search structurally to find a specific type of pattern in my code base. But I'm not going to show the details of that. So if in doubt, if you can't really find, if you don't know what you're looking for, if you can't remember a keyboard shortcut, if you don't know where the file is, you do double press on Shift, and that does search everywhere. It'll search in the files, it'll search in your method names, it'll search for actions, it'll search like literally everywhere. So if I say, I don't know, debug, what have we got? It gives me a list of symbols, so methods that I could go to. It gives me a list of actions and a bunch of other stuff. So like settings I can turn on and off. So the one keyboard shortcut that's totally useful to remember that I learned very recently actually is search everywhere, press Shift twice, and it gives you everything you might want. There's like way more to go on about, obviously, but conveniently, I already did a video about this and it's on YouTube. So if you really care, you can go and watch an 8-minute video specifically on navigation in IntelliJ IDEA. There, I've done my pitch for today, so I'm good. I can carry on ranting now. Okay, code is meant to be run. So code, yes, of course, it's supposed to be readable. We're supposed to be able to read it. But at the end of the day, it's not a novel. It's not meant to be read to end to end. It's meant to be run on a computer. If you don't think about the underlying mechanics of the simulation, even if that thinking happens in a semi-conscious way, you won't last very long in the game. You have to probe to progress. Now, this is a book I'm reading at the moment about, it's called Everything Bad is Good for You, How Popular Culture is Making Us Smarter. It's basically a way to justify watching television and playing games. It's fantastic. This quote is about like how games actually encourage you to explore, to probe, to have a mental model of the underlying workings of the game in order to like progress further. And it reminded me a lot about being a programmer. So you can't really, you can't progress understanding the code unless you get a feel for what it looks like when it's running. It's not just text on a screen. So let's once again take a quick look at the IDE. So obviously I can, this is one of the tests, I can run this test. I'm going to debug it. And my computer rebooted, so now it has to rebuild all of everything. All right, so let's debug this. And let's see what we get. Oh my God, I hate doing stuff live. You end up having to wait so long. Java's not slow. Java's like, oh, you know why? Because my computer rebooted itself and I need to have MongoDB running. Quick, what could go wrong? Yes, I am using Windows. I know that's not trendy amongst developers these days. I also use a Mac. I also have Linux. It's just the Surface is a much lighter machine to carry around with me. Right, so MongoDB is running. Let's rerun our test. So yes, as you notice, this is an integration test, not a unit test. I tried to find a unit test. There weren't any. Never mind. The reality of real life code. But the good thing about having complicated integration tests is that they have much more interesting stacks when you start looking at them and debugging them. So here we are. Let's look here. Oh, let's drop a frame. Where am I? Sorry, let's do that again, because I was a bit keen. So I'm going to debug it. And when we get to the place I quickly went too fast past. Next one. So here we are. The great thing about high resolution displays is you can't see anything when you put them on a big screen. Right, so here's the debugger, here's the stack. So we're in a method called createQuery, which is the method we were looking at earlier, which is called by a method called createQuery, which is called by newQuery, which is called by createQuery, which is called by find. I did not write this code. We don't judge this code, we accept it for what it is. Okay, this is just the reality of the situation. And so then I get a feel for like the chain of calls that happens in order to get to that place. So I kind of know what's kind of vaguely what's going on there. And then I can also, let's get rid of that there. I can also, I can see here, you can't see because it's too small, but I can see here the currently live variables. If you're using IntelliJ IDEA or I assume Android Studio as well, you also get the sort of fake comments which tell you what's happening in line with the things which are happening. Let's see, let me just try and, live demos, I just really hate them. I did something, I did something while I was practicing and I was like, oh yes, I'll show that when I demo it, and now it's already done, so I don't need to show it. So if we look at something like here, it's displaying data store as the standard like object pointer thing, which is not very helpful when I'm trying to debug this. In IntelliJ IDEA, I can actually say, right, I don't want to display that as that. I'm going to right click, say view as. I'm going to create what's called Java type renderer. And so when you show me this in the debug view, I want to see it in a particular way. I can say, use the following expression. So I'm going to say this, which is data store, get this database, get name. So instead of showing the object reference, when I see data store, I want to see the name of the database it's pointing to. So then I say OK, and the debugger will start showing me that information instead. So that's like a really useful way, because of course, just the object pointer thing is like super not helpful. And so we end up writing two-string methods all over the place when we don't even really need them, but we can actually use things like Java type renderers to help us when we're debugging. So there's a bunch of tools here inside the IDE which are meant to help us with this kind of thing. Because code is meant to be run, we should be running it, we should be analyzing what's happening there. We should be having a feel for like what are the variables which are here, what do they look like. The other thing we can do is we can do things like, so there's a variable called type. I can actually set the value here. So I'm going to change this, I'm going to call it test. And then I can carry on running with like a new value in there. So this is particularly helpful if you're trying to debug production type issues and you've got like some set of state somewhere that you can't emulate somehow in the test. You can't set up the test that way. You might be able to manually poke stuff inside the debugger to set stuff up into a particular state and then see what happens. Okay, so you can manually do that. There's also something called evaluate expression, and you can type whatever you want into there and evaluate it. And that will show you the result of that, but it will also make that change as well. So you can sort of start poking like random Java code at it to see what happens. Okay, so that's the debugger. Oops. Oh my goodness, I've just totally had a blank on all my keyboard shortcuts. Debug and stop. So code is meant to be run. You need to run it to understand it. And obviously you have tools that can help you understand it. In fact, you don't even always need to run it. So code analysis tools, which I know you have some internally anyway, but IntelliJ IDEA will tell you things like, this method is never called. Perhaps you might want to delete it. So that will help reduce the cognitive load if you just kind of get rid of the stuff which is like never used, for example. If you absolutely must write something when you're trying to understand something, please write tests. That's a good place to start. So like write some unit tests, write some integration tests, like write test code to sort of test your hypotheses of what's going on. Again, from the model of playing games. The game scholar, I didn't even know it was possible to be a game scholar. Wish I'd known that when I was at university. The game scholar, James Paul G, no relation, breaks probing down into a 4-part process, which he calls the probe, hypothesize, reprobe, rethink cycle. And this sounds quite a lot like scientific method / testing. So do something, make a hypothesis, change something, test that hypothesis, and loop back round again. So it sounds like testing. So if we need to test our hypotheses, if we need to kind of get a feel for, is this really, I have this mental model, I'm not really sure if that's quite right, write a test it, see if it is right. You don't even necessarily need to check that test in, you could just throw it away. Speaking of which, if you really, really, really must change the code, throw it away. Like, obviously not when you're fixing a bug or implementing your day job. I mean, like, when you're trying to understand something. This Morphia code base every time I was trying to read it and understand it, my instinct was just to try and refactor it, especially because IntelliJ is saying, oh, do you want this as a Lambda expression? I'm like, yes, please. And you just kind of like, as you're reading, you're actually writing at the same time. It's not really, I don't think you're using the right part of your brain if you're just making changes all the time. But again, if you have a hypothesis and you want to test it, then you could try doing some refactoring. You could try some of like IntelliJ's suggestions or whatever, but throw it away. Put it on a branch or stash it or shelve it or whatever you want to do, and do it because it's good exercise, it's good learning, but throw it away. I went on a pottery course for random reasons, and the teacher sort of says, do this thing and create this thing, and you spend like 15 minutes and you create your little pot. It's kind of a bit crap, but that's, because it's your first pot. And then he says, throw it away. I was like, no. He says, well, you're not doing that. That was just for practice. That's just to get your fingers used to doing the thing that it needs to do in order to move on to do the real thing. And I'm like, I can't throw this away. Like, I made it. But he's like, no, the pot is not the end result of what you just did. The learning is the end result of what you just did. Throw the pot away and keep the learning. And that's what we should be doing with code. And the ridiculous thing is that code is like way more throwawayable than a pot. Okay, but we never throw it away. We're just like, yes, well, I wrote that, so I'm going to keep it. Let's not get attached to stuff. Let's experiment. Let's try things. Let's refactor things, but then throw it away. Okay, my final tip is that not all knowledge can be codified. So even if we are writing readable code, which we all are, and we are not always able to capture all of our assumptions, all of the ways we were thinking, all of the business knowledge, we can't necessarily capture all of that and write it down in the code. So it's not always available inside the code. Nice long quote. It may or may not have helped Anathema to get a clear view of things if she'd been allowed to spot the very obvious reason why she couldn't see Adam's aura. It was for the same reason that people in Trafalgar Square can't see England. Now, if you don't know your geography of England, Trafalgar Square is right in the middle of London, and you can't see England if you're inside England, can you? Because it's like all around you. And the code is a bit like that as well. So this is a very tenuous analogy. I just really like that quote. If you are looking at lines of code, even if you're navigating, even if you're drawing diagrams and trying to get a feel for the shape of the code, ultimately you're still inside the code and you don't always know what's happening at the bigger picture level. So sometimes you need to draw back and not just be looking at the code. And so that means, that you're going to have to talk to people. So sorry that you have to hear that. But it's not just about reading code and writing code. All those notes you were making, all those assumptions, all those questions, all those diagrams, like show them to your colleagues and say, does this seem sensible? Did I miss something? Or like, did you know this? And share that information and try and get some more learning off the back of that. It's also quite a good way to, I hate to use this word, like document your system, maybe, write documentation. Or people are always asking me, like, how do I get started with public speaking? And things like brown bags, where you do a lunchtime presentation to your colleagues about, I found this interesting thing. This reading code and learning stuff and then presenting it to your colleagues is a great way to just improve a whole bunch of your programming skills. And by programming skills, I mean becoming a well-rounded developer with communication skills, not just typing on a keyboard. Right, so let's just summarize the tips. In order to get good at reading code, you have to practice. There is no quick fix to this. Reading is not the same as reviewing. We need to read it and accept it and live with it. Code bases have a shape. Code bases have a dialect. Code is not linear. Code is meant to be run. If you must write tests. If you really, really must change something, throw it away. And not all knowledge can be codified, so it's not all about just reading the code. Sometimes it's about talking to other people as well. So ultimately, when I'm reading code and I think, I don't understand, it's not because the code is bad, and it's not because I'm bad. I just have to accept the code. I have to practice reading it. I have to accept the situation I'm in. This is a quote from my eldest daughter's favorite book. I'm grizzly and grumpy and grouchy and grumbly. I've not been called lovely before. This is a very heartwarming story about how a giant is like accepted by the children. But the point is that the children just accept him for who he is, and they don't like judge him based on the fact that he's a big grumpy giant. And it should be the same with our code bases. I was not really reaching for quotes at all here. We should be able to accept the code for what it is and live in it and get to know it better instead of just automatically judging it based on this is bad code or I'm a bad developer. Which was kind of my conclusion, but I have more conclusion because I'm always terrible at tying up the end of my talk, so I have like way more conclusion. Code is for reading. We know this. We know that code is read by a computer, of course, and it's read by a programmer, a developer, maybe even other people as well. Uncle Bob says, indeed, the ratio of time spent reading versus writing is well over 10 to 1. There were no statistics to back this up, but I'm sure that it feels about right, probably 10 to 1, or depends a bit on the code base, honestly. But then he goes on to say, we're constantly reading old code as a part of the effort to write new code, making it easier to write code. So he talks about, like, we read code all the time, but once again, the whole thing is phrased in the context of writing code. We read code in order to write it. It's a bit circular as well. Like, we need to write better code because we read code because we're going to write code. But there's so much effort on this whole, like, writing code, teaching how to write code, writing readable code, and not enough effort focused on like learning to read code, learning to accept code, learning to live with it and learn from it instead of wanting to change it all the time, instead of wanting to write it all the time. So final thought from Jane Austen. My fingers, said Elizabeth, do not move over this instrument in the masterly manner in which I see so many women's do. They have not the same force or rapidity and do not produce the same expression. But then I've always supposed it to be my own fault because I will not take the trouble of practicing. It's not that I do not believe my fingers as capable as any other woman's of superior execution. The key is practice. It's not just about practicing reading code or writing code. It's also about practicing the ability to read code without judgment, without reviewing, without being critical. So I surprisingly actually have time for questions. I'm absolutely amazed. Do we have any questions? And so this URL is like, it's not fully fledged yet, but my slides are up here and a bunch of links to the stuff that, that I've referred to, and there will be more stuff on there later. Yes?
Yes, first of all, thank you for coming.
Thank you.
Also, I love IntelliJ, so thanks for that too. So I know that IntelliJ has a bunch of tools, and some of the tools help like visualize structure of code and show diagrams and things like that. Do you find those useful? Do you have any tips on using them effectively? Any favorites for that? I'm
really glad you said that because I've totally forgot to demo that. So yes, there's a whole bunch of stuff in IntelliJ IDEA, so I can do things like, let's see, where I am right now, where am I? So that's a test. Let's go to the non-test. I can do things like diagrams, show diagram. I can show myself a class diagram, so it can sort of show me some of my dependencies and stuff. If you do it at the sort of package level, let's do this just because it's fun. Show diagram, Java class diagram, and it will show me everything. I would say this ranks on the less useful scale of the diagrams, but actually if you zoom in, it does tell you some useful stuff. So for example, will you let me zoom, or is this, oh no, fine. So it tells me some useful stuff like, well, that's not very helpful. But you can see there's some stuff which is kind of like isolated and on its own, and a lot of stuff which are, oh my goodness. Oh, well, that's tests, so that's kind of, I guess that's understandable. By the way, test-based should be called integration tests, so you can see you need a MongoDB instance running. So you do get some useful information from that. I tend not to use these very much. I feel like I should. What I did is I did use the Java module diagrams when I was trying to migrate to using Jigsaw and using Java 9 modules, because that actually really helped me visualize the dependencies and see what was kind of like weird, skewy dependencies and stuff like that. And I want to use the dependency diagram a bit more for, again, for sort of migration and stuff like that. It's really helpful to get a feel for what your dependencies are. I have generally found, not just IntelliJ, but generally found that generated diagrams not super helpful. Especially like I would never like save one somewhere and put it on a wiki or something because it's going to be out of date instantly. But it is kind of useful to go, oh, look, there's that thing. Let's go away and refactor that stuff.
Thanks.
Hi. Do you have any tips on how to start reading a completely new code base to you? Like you just came to the team and there's like a bunch of code. How do you get into it?
Yes, so I was originally going to do that talk, but then I saw another talk by another Patricia on exactly that topic on YouTube, and I was like, well, I'm not going to repeat all of that. So she has this whole talk where she talks about specifically like, where do you start? Which tools do you use? How do you drill down? How do you get started with a code base that you don't understand? It's from the context of trying to contribute to an open source thing, but it's basically the same thing. But a lot of the stuff I was reading around this topic were, you know, find a thread, find an entry point and pull on it and kind of chase it down to start building up this mental model of what the thing does. So yeah, I think that what I wanted to do with this talk was kind of say my first step when getting into a new code base is to try and think, it's not how I would do it, but that's okay. It is what it is. Because often we're reading a new code base and it's complicated, it's confusing, it's just not really what I did in my last project. And so I'm constantly thinking, I want to refactor this doesn't feel right, this naming is all wrong or whatever, instead of thinking, okay, what's here? How does it talk to itself? Like how do I, and what I want to do is start drawing diagrams to sort of model it and building up my mental model of that code base. So I guess the sections I was talking about in terms of finding what the code shape is, understanding the code dialogue, that's understanding the code dialect, that's where I would sort of start, try and get a feel for what's there, and then start drilling down and navigating through it. I don't know if that really helps, but go away and watch this other talk, because it's really got very solid points on how to do that. It's called Reading Other People's Code. I've got a link to it on my, I don't have the internet. I've got a link to it on this page, actually. It's called Reading Other People's Code by Patricia Ass. I'm not really sure how to pronounce her surname. It's A-S-S. Yes.
Thanks for the talk. I just want to abuse your literature analogy a little bit. So when we teach kids to read, we give them quite a carefully designed curriculum of material and things are pitched at the right level. But when we as developers read code, we go straight to Shakespeare. Do you think we need a reading program?
Yeah. So I've been thinking about this because I've been thinking about how do we teach people to code from nothing. So a lot of what I do as an advocate is teaching people who already know how to code tips and tricks to make them more effective. It's much easier to teach that because you already know how to code. Teaching people to code from the beginning is really difficult because you are trying to figure out, okay, so is Hello World really the most useful way to teach people? And often when you're teaching people Java in particular, because it does have a certain level of boilerplate, the first thing you do is you give them the Hello World app and then you say, right, but ignore all of these lines because you don't know what they mean. So I do feel like there's a need for like a curriculum, a skill tree, some way of like starting from something simple and building up from that. And I would like to build that. And every time I think about it, I'm like, oh my God, that sounds like loads of work. But I would like to see people and places that teach Java start to think about how people are going to be reading the code as they learn. Because obviously when you learn from a book, which a lot of us do, it's written down, you can't play with it, you can't navigate. So your code examples do have to be sort of carefully chosen, but I'm not sure that they are currently, I think they're chosen in a way to showcase the features of the language instead of chosen to showcase what I as a developer will be doing in the real world. So it'll show you like hello world in Java instead of like how to create a simple app with like a Gradle or just some sort of dependency management system, and how to use Git in amongst all of the Java stuff as well. Okay.
So just following on from that, so my daughter is 5. She just had her first computing lesson yesterday. I'm very concerned, though, that she's being taught by a primary school teacher who is not a developer. I really love your point about we teach people to write code but not read code. But I sort of feel like we need this structured curriculum in order that they're taught the right thing, rather than they're taught to code down just a crazy path that's just completely useless to people.
Yeah, and whenever you see stuff that's just teaching for kids, they start with things like Scratch or Minecraft or something which is kind of appealing for kids sometimes. And some of that's great because it's appealing for kids, and then you plonk them inside IntelliJ IDEA and say, write Java, and they're like, this is nothing like what I just did. So I don't really know what the answer is yet, but I definitely think we should be thinking about teaching code the way that we teach a language. Let me expose you to some simple real world examples, and then you can go away and start playing with those and maybe building on from those.
Yeah, I would love to go to my daughter's school and take that idea, because I suspect that the teachers might actually feel liberated by that idea of, oh God, I've got to teach them how to construct this thing that I have no idea how to construct.
Yeah, so my parents are teachers, or they were teachers. My mum was a primary school teacher and my dad was a secondary school teacher. And they did teach a certain amount of IT, and my mum was responsible for IT in her school. But she had an advantage in that me and my sister both studied computer science, so we could help her to teach IT. Most teachers in that position, they don't have that knowledge. They're having to learn so much stuff of their own. How can they teach English and maths and geography and science and all these things and computer programming, because they just don't have that expertise. And in my experience, they would welcome an expert coming along saying, I do know how to do this. I can help you with it, or I can take the class or whatever. They really would like the real world expertise to come in and help them with that stuff.
There's the joke in The Simpsons about Marge Simpson teaching kids to play the piano by staying 2 lessons ahead of them.
Right, exactly. It's difficult because teachers who teach in the schools, especially primary schools, they don't have that experience, so they don't really know how to teach this stuff. Granted, we have the experience as developers, but we don't have experience as teachers, so we don't really know how to teach people either. So it has to be some sort of collaborative effort there.
When you were talking about reading over here.
Thank you. Where are you?
When you're talking about reading code just to understand it and appreciate it, I was thinking so much about when I'm looking to integrate with some new library or service and I'm reading their documentation, and thank God it has sample code, because that's always the thing I want, because it helps illustrate the story essentially. How do you think we go about, do you have any tips for encouraging other people in their documentation to follow that paradigm more closely? Because I feel like it's such an important part of helping us understand.
This is really hard. When I was working on the MongoDB Java driver, what we were quite thorough in providing the Java doc comments. So we had Java doc documentation. We had a small tutorial walkthrough, and we had some documentation too, but we knew what we wanted was snippets of code that people would basically copy and use in their to get started in their own project. The challenge is that those snippets of code are not usually run in your build system, so they get out of date really quickly. The same way that comments in your code get out of date, if you've got code in your documentation, that gets out of date too. So what I would really like to see is a system whereby your code is also run through continuous integration. But that's kind of difficult, especially with Java, because we're talking about a snippet of code that in the case of MongoDB, needs a MongoDB server running. It needs to be set up in a particular way. You've got like a whole bunch of other prerequisites which need to happen beforehand. If we had a system whereby you could build like living documentation with real working code snippets in, it would be much easier for developers to sort of just throw up a code snippet, have it compiled, have it built, and know that if you change the code under the covers and it breaks it, we can fix that as well. There are some companies that have done some of that. I know that Neo4j built their own system to do that, and I think probably Pivotal do it for some of their Spring stuff. But it's not like you can get an off-the-shelf thing and say, look, this is how you do technical documentation for Java. If we had something like that, it would make life a lot easier.
I'm going to play a little bit of devil's advocate here. So there's a recommendation when you're working with legacy code, like you see something, you read, and you kind of spend the most of the time that you need to refactor and improve it. So like, why not doing that right away? And this way you can improve the whole code base. So how would you answer to this type of thinking?
Yeah, I mean, there's always that tension between, especially, well, I say an older code base, but like, you know, an old code base is a code base which is like 6 months old or older, right? Stuff moves so quickly. How do you modernize a code base? Do you do it in like big bang? Do you do it like, do you do it across layers? Do you do it as you're working on particular features? It's really challenging. And there's also the Uncle Bob thing of you should clean up as you go along. So if you're working on a particular method, you can make those changes. It's always going to depend a little bit. I think the most important thing is that your team has to pick an approach, and you all have to be on board with that approach. Because sometimes if you decide that if I'm going to fix this bug and it touches these lines of code, I'm going to clean up those lines of code. Someone else, your code reviewer, is going to say, I don't want that in there. I want the feature first, and I want refactoring separate, right? And other people are going to have other approaches. So whatever approach you take, the whole team needs to be on board with it, and it needs to be part of the review process as well. So for example, right, you fixed this bug, but you didn't clean up these errors, or vice versa. You fixed the bug and you did refactoring, and I want those things separate. So it's kind of challenging. One of the other things is that I've worked at very large enterprises where really the safest thing to do is not do the refactoring. You want to, and it feels like it will help you, but often there's whole modules which really, there's the amount of pain to refactor is not going to pay itself back. You don't change it often enough to warrant 3 weeks refactoring it, or you don't have enough test coverage to safely refactor it. So there's also going to be times where you're like, we should not modernize it, we should not refactor it, which makes me sad, but that's sometimes the way it is. Does that vaguely answer your question?
Yeah, but like you still think that we shouldn't think about refactoring during reading. So this should be two different separate activities, right?
Yeah, I still think the refactoring kind of is part of the writing phase. Now, this also comes into one of the other things I rant about, which is that we don't always pay enough attention to technical debt. So we often have to do refactoring when we're fixing a bug or introducing a feature, because that's the only time we're allowed to make those sorts of changes. But we should perhaps be specifying time for refactoring or migration or updates or whatever separate to bug fixing and feature additions, if you like. But it's still, the refactoring is still a writing activity ultimately. We can be making notes. This is another thing we could be doing while we're reading, when we're making our notes. I would like to change this area. This area seems like it's right for these sorts of refactorings. But ultimately, when we're reading the code, we can be thinking about tickets to open for stuff to do in the future, but we shouldn't be doing it as we're actually reading the code.
Last question, right?
When I'm reading code, sometimes I feel like I focus too much on control flow as opposed to, and kind of neglect things like structure. So the diagrams was really neat. Are there other ways of looking at the overall structure that can help you understand maybe more of the implementation detail that's hidden underneath?
Probably. The thing that interests me from what you just said is that I think everyone comes at stuff from their own different approach. So you said that you're interested in control flow, for example. Other people read code and they they automatically see maybe the business domain. And other people, like for me, I just get caught on the stupid details, like this bracket is not in the right place. I think probably step one is to understand, like, what are the bits that we are good at? What are the bits that what are the mind states we constantly fall into, like thinking about control flow? What are the other things that I should be thinking about that I'm not thinking about? For a lot of us, that's quite often, what is the business domain? We're so busy thinking about the lines of code, we're not thinking, okay, but what is actually the domain that we're working in? And different types of diagrams can definitely help with that. For me, when I was working at the financial exchange, I kept having to go back to the architects and the business analysts and saying, can you like draw on the whiteboard, like what, not necessarily the flow, but what like the business cases really are, because I'm not seeing that reflected in the code itself. So some of that stuff is diagrams that can be generated, but some of that is literally like knowledge you have to pull out of other people's heads because it's just not there in the code base. But it depends a little bit on how we think and which bits we focus on and which bits we don't look at closely enough. Does that help?
Okay.
Okay.
Thank you very much, Trisha.
So for the next hour, we have lunch. There's lunch outside in the hallway there. And if you prefer something different, there's Till Cafe in the same building that way. Trisha, are you planning to stick around? Do you want to chat with people?
Yes. Yeah,
Okay.
I meant to mention, I'd like to stick around. Please come and talk to me about anything like IntelliJ or Java or ranting about whatever.
All right. Thank you.